this is question number 1 of the October-November 2024 paper. So let's read the paragraph over here. So it says that the velocity of a particle moving in a straight line at time t seconds after leaving a fixed point O is v meters per second. The diagram shows a velocity time graph which models the motion of the particle from t is equals to 0 to t is equals to t. The graph consists of 4 straight line segments. The particle accelerates from rest to a speed of v meters per second over a period of 4 seconds and then decelerates at 5/3 meters per second to instantaneous rest over a period of 6 seconds. The particle then travels back towards O, reaching a maximum speed of 3 meters per second before coming to rest at time t is equals to t. So this is a lot of information to take in. But so first we'll understand the movement of the particle as well as the nature of the question. So this is a velocity time graph, which means that dv over dt, also known as the gradient, must be equals to the acceleration. So they told us that there are 4 straight line segments. This is segment 1, this is segment 2, line segment 3, and this is line segment 4. So that means that each of these line segments has a different gradient, hence a different acceleration. And now let's learn about the movement of the particle. So they're saying for the first 4 seconds over here, the particle starts from rest as shown, since it's starting from the point 0, 0 from the origin, and then it goes and reaches a speed of v, which is unknown, and they've not given us the acceleration as well. So acceleration is unknown, as well as for the second line segment, it starts with the speed of v, which is unknown again, but this time they've given us the acceleration, and that is -5/3 since it is decelerating. So for this line segment, the acceleration is -5/3, and the time taken is 6 seconds. And then finally it reaches a rest over here, since at this point velocity is equals to 0, and then it moves in the other direction as it is traveling backwards. Hence the velocity is negative, but the speed is 3, since velocity is speed in a given direction. They've not given us the acceleration again, and they haven't even given us the acceleration of the final line segment. So this is all the information that they've given us, and the total time, which is t, is also not provided to us as well. So let's start reading the first part of the question. It says, part A says we need to find the value of v. This is v over here. This is the final velocity of the first line segment, but the initial velocity of the second line segment. So we can solve this question in 2 ways. One is using the idea that I mentioned over here, which is that acceleration is the gradient of the line, and the other idea is that we can use the v is equals to u plus at formula, in which v is the final velocity and u is the initial velocity, a is the acceleration, and t is the total time taken. So if you look closely, we can find out v only using line segment 2, since we're given enough information, while segment 1 won't be useful as the acceleration is missing as well as the final velocity, so we'll have 2 missing variables while using this formula. So let's use this formula for segment 2 and write down the information. So the final velocity, which is capital V, we will write this as 0 since it comes to instantaneous rest over here. The acceleration is -5/3 as we have established before. Total time is 6 seconds, these 6 seconds, and the initial velocity is v, this v. which is 0, is equals to initial velocity v plus negative 5 over 3 times the time, which is 6. So if we solve this, that means that v is equals to 5 over 3 times 6, which is 10. So the value of v, capital V, over here is 10. The second part, part B. So for part B, they're saying, given that the total distance traveled by the particle from t is equals to 0 to t is equals to t, capital T, is 68 meters. Find the value of t. So as I said before, this is a velocity time graph. And whenever we talk about velocity, we know that whenever we integrate velocity, we get the displacement. The other thing we know is that if we take the area under the graph, that is equal to the total distance traveled. What that means is that if we find out the area, this area over here and the area over here, that will be equal to 68 meters. So we can write down x is equals to 68 meters. So if you look closely, these are all triangles. Like this is one triangle, triangle 1, this is another triangle, and similarly this is another big triangle over here. This can also be one big triangle. The total distance traveled was 68. This is equals to the area of triangle 1, this triangle, triangle 1, plus the area of triangle 2, which is this triangle. So that means 68 is equals to, so the area of the triangle is half times base times height. For triangle 1, that is half. The base is these 10 seconds. And the height is the value of v, which we found out as 10 in the previous part over here. And then the area of triangle 2 is this. So that's half times the base, which is this. So this is 10 over here and this is t over here. That means the base is 10 minus t, sorry, t minus 10. Times t minus 10 times the height, which we know this is 3. We won't take the negative sign since that is only indicating the velocity, but if you look at it objectively, the length of this line is 3. So I just removed the thing I wrote over here since I don't have much space. So if we start calculating this, this is half times 10 times 10. 10 times 10 is 100, and 100 divided by 2 is 50. So we'll write this thing as T2. So that means that the area of T2 is 68 minus 50, which is 18. So the area of this triangle over here is 18. So I'm just gonna erase this since I don't have much space left. So we established that the area of T2 is 18. That means that 18 is equals to half times 10, t minus 10, which is the base, multiplied by 3 is 18. So let's take this to the other side, which means you have to divide it. So it's 18 divided by 3 by 2, which is, so 12 is equals to t minus 10. So if you find out the value of this t, which is the total time, that would be 12 plus 10, making that equals to 22. So now we have found out the value of t, and that we're done with question number 1. This is question number 2. So a block of mass 20 kg is held at rest at the top of a plane inclined at 30 degrees to the horizontal. The block is projected with speed 5 meters per second down a line of greater slope of the plane. There is a resistive force acting on the block. As the block moves 2 meters down the plane from its point of projection, the work done against this resistive force is 50 joules. Find the speed of the block when it has moved 2 meters down the plane. So first we're gonna draw the diagram that represents the situation. So I'm gonna draw a hill. So let's say that this is the hill, and it is inclined at an angle of 30 degrees to the horizontal. So this angle is 30 degrees, and the a block of mass is sitting at the top of a plane. This is over here. So it has a mass of 20 kg, which will make its weight 200 kg. So as you know that this line is parallel to the line of greatest slope, that would make this angle over here also equals to 30 degrees. And it would have a downward component of the weight and a rightward component of the weight. So this downward component will be equals to 200 cos 30, and the rightward component will be 200 sin 30. This is the normal reaction of the plane, and there is no mention of a driving force, so I will not write that down. That means that the object is moving downwards to the plane due to this rightward component of the weight that is pulling it downwards. They've also mentioned that there is a resistive force, which in this question will be the friction. So since the movement of the particle is downwards and friction always acts opposite to the movement, that means that the friction will be moving it upwards this way. So let's write down the other information that they've given us. So it is saying that it is projected with the speed 5 meters per second. So we will write down that as the initial speed, which I'll write as u, which is 5. The final speed of the block is not given to us, so that is, we'll write down that as v, and that is unknown. The block has moved 2 meters down. That makes the distance traveled, which I'll write as x, as 2. And finally, the work done against a resistive force is 50 joules. So that means that the work done against friction is equals to 50. Now this question is requires the use of a energy method, which uses a very simple formula, which is that the total work done by the driving force is equals to the change in kinetic energy plus the change in potential energy plus the work done against friction. So we already have this third component, which is equals to 50. And since there is no driving force in this question, since the particle is moving downwards due to this force over here, this component, the total work done due to the driving force, must be equals to 0. As well as for the change in kinetic energy and the change in potential energy, the formula for change in kinetic energy is half times the mass times the final velocity squared minus the initial velocity squared. As for the change in potential energy, that is the mass times the force of gravity times the change in height. So we know the mass of the object, we know the force of gravity is equals to 10, we have the initial velocity over here. So, and the final velocity is the unknown variable over here. So we need to find out the change in height. Now how can we do that? That is we can use a very easy method. So let's say that this is the hill again, and this is the height of the hill, and we were told that it is inclined at an angle of 30 degrees over here. So, and it is told to us that the total distance traveled downward is 2 meters. That would make the hypotenuse equals to 2. And this change in height, so if we use a trig ratio, we can find out this change in height over here since we're given the angle. So we have three trig formulas. We have the sine, the cos, and the tan. So if you see that the sine theta is the best fit, since sine theta in this case will be sine 30 is equals to the perpendicular, which in this case is the change in height, times the hypotenuse, which is 2. So change in height must be equals to 2 times sine 30, and that is equals to 1. And you will notice that the particle is moving downwards. So this was the initial height h1, and this is the final height, which is h2, which is 0. That means that the change in height is negative, since it is moving from this height over here to a height over here, which is 1. So now we have all the pieces of the puzzle, and we can write down. So 0, which is the total work done against the driving force, must be equal to the change in kinetic energy, which is half, times the mass, which was 20, times the final velocity, which we don't know, minus the initial velocity, which was 5 squared, plus the mass again, times 10, which is the force of gravity, times change in height, which is -1, plus the work done against friction, which was given to us as 50. So let's simplify this. So this is change in work done. This is equals to 20 times 10 times -1. So this component is -200, and if we add the 50, that is -150. And taking this -150 to the other side, 150 is equal to the change in kinetic energy, which was half times the mass times v squared minus 5 squared. So let's simplify this further. 150 is equals to, this is equal to 10 times v squared minus 25. So let's divide 10 on both sides. That will mean that 15 is equals to v squared minus 25. So that means v squared is 15 plus 25, which is 40, which makes the final speed, which is v, equal to under root 40. Cyclist is riding along a straight horizontal road. The total mass of the cyclist and his bicycle is 90 kg. The power exerted by the cyclist is 250 watts. At an instant when the cyclist's speed is 5 meters per second, the acceleration is 0.1 meters per second. So for part A, we need to find out the value of the constant resistance to motion acting on the cyclist. So resistance to motion is always friction. So friction is the unknown variable. Other than that, we're going to make a diagram which represents the situation. So let's say this is the straight horizontal road, and this is the cyclist and the bicycle. So the mass is 90 kg, which means the weight is 900. So there is a downward force of 900, which is the weight. This is the normal reaction. And since it is moving forward, that means that the cyclist is exerting a certain driving force which creates power and makes the bicycle move forward. And then there's a mention of the resistance to motion, which is friction. Friction always acts opposite to the intended motion. So that means friction will act leftwards, like this. So other than that, let's write down the other information that they've given us. First, they have told that the power exerted by the cyclist is equals to 250 watts. And then at that instant, the cyclist speed is 5. So the speed or the velocity is 5. The acceleration is 0.1. Another important thing to notice is that they have used the word at an instant. That means that this power given to us over here is instantaneous power. And the formula for that is the driving force multiplied by the velocity. So we have the total power, which is 250, and the driving force is missing, but we have the speed, which is 5. So that means the driving force is 250 divided by 5, which is equals to 50. But now we have to find the friction. So for that we can use the forces formula, which is forward force, or the driving force, minus the resistive force is equal to the mass multiplied by the acceleration. We have the mass, we have the acceleration, and we have the driving force. So we can find out the resistive force, which in this case is friction. Forward force is 50 minus resistive force is equals to 90, which is the mass, times 0.1, which was the acceleration, which means 50 minus the friction is equals to 9. That means friction is 50 minus 9, which is 41. So that means that the resistance to motion is 41, which we have found out. So moving on to part number 2. Let's read the question. The cyclist comes to the bottom of a hill inclined at 2 degrees to the horizontal. So part B says that given that the power and resistance to motion are unchanged, find the steady speed with which the cyclist could maintain while riding up the hill. So first we're going to draw the diagram. So I'm going to first make the hill. This is not scaled. So it is inclined at 2 degrees over here. So that means this angle is 2 degrees. And it is at the bottom of the hill. So I'll just draw it over here. So when we resolve the weight, the angle inside becomes 2 degrees as well, and the downward component becomes 900 cos 2, and the rightward component becomes 900 sine 2. There is a normal reaction as well. Now they're saying that the cyclist is riding up the hill. So that means that he must be exerting some sort of driving force over here. And there is friction again, which they have mentioned as unchanged. And we found out the friction to be equals to 41 newtons. So it is opposite to the force intended movement. So it will act in this direction, and it is equals to 41. So other than that, they have also told us that power is unchanged, and power was equals to 250 watts, and it is told that it was moving at a steady speed. That means it is moving up at a constant speed, making the change in velocity or the change in speed equal to 0, which is acceleration. So acceleration is 0. And so this is instantaneous power again, and we'll use the formula that we used before. Power is equal to the driving force multiplied by the velocity. But in this part, both the driving force and velocity are missing, but we only have to find out the velocity, which is the unknown variable. So that means to find out the velocity, we first need to find out the driving force. Like in the previous question, we'll use the forces formula, which was the driving force minus the resistive force is equal to the mass multiplied by the acceleration. The driving force is unknown, and in this case we have two resistance to motion. Resistance to motion are those forces that are stopping the object from moving in its intended direction. So that in that case, that will be the friction as well as this downward component of the weight. So driving force minus 900 sine 2 minus 41 must be equal to the mass, which is 90, and we found out the acceleration to be 0. This becomes 0. So if we take 900 sine 2 and 41 to the other side, the driving force is equals to 900 sine 2 plus 41, which is equals to 72.4. And now we can use this and substitute it back into this formula. So that means that 250, which was the power, must be equals to 72.4, which was the driving force, multiplied by v, which is the speed, making the velocity or the speed equals to 250 divided by 72.4, which is 3.45 meters per second. So with that, we're done with question number 3. So this is question number 4. They've given us a diagram, and other than that, they've given us this paragraph. So let's read that. The diagram shows two particles A and B of masses 0.2 kg and 0.1 kg respectively. The particles are suspended below a horizontal ceiling by two strings AP and BQ, attached to fixed points B and Q on the ceiling. The particles are connected by a horizontal string AB. Angle APQ is 45 degrees and BQP is theta degrees. Each string is light and inextensible. The particles are in equilibrium. So all this is describing what is already shown in the diagram over here. The only additional information that I've given us is that the particles are in equilibrium. So what that means is that if a particle is in a state of equilibrium, the forces acting upwards on the object must be equal to the forces acting downwards, and the forces acting leftwards must be equal to the forces acting rightwards. So we need to resolve the tensions in the string as well as the weight. So particle A has a mass of 0.2 kg, which means it has a downward component of 2, downward weight of 2, and B will have a weight of 1, which acts downward as well. Other than that, we have two strings, this AP and this BQ over here. So for that, we will need to resolve those. So since this weight is pulling it downwards, that means that the direction of the tension must be like this. I will call the tension in string AP as T1 and the tension in BQ as T2. But these need to be resolved as they have two components. So make them into a triangle. So this that means that it will have a upward component like this, and this will be T1 will have a leftward component, while T2 will have a rightward component. The upward components will be T1 sine 45, and this will be T2 sine theta, and this leftward component will be T1 cos 45, and this will be T2 cos theta. With that, we are done resolving the forces. Now for part A, they say we need to find the value of the tension in string AB. That is this string over here. This is a horizontal string, so instead of looking at this as a system, we will only focus on one particle, and we will use particle A because in that we only have one unknown variable, which is T1. If we use T2, we would have two unknown variables, which will create almost three simultaneous equations. So we will use only particle A. So particle A is in equilibrium. So the forces acting upwards is T1 sine 45, which will equal to the weight, which is 2. That means T1 is 2 divided by sine 45, making T1 equals to 2 times under root 2. But what we need to find is the tension in the string AB. So for particle A, the tension in the string AB will act in a rightward manner like this. That means that for the second condition, for the rightward forces to be equal to leftward forces, that means the tension AB must be equals to this T1 cos 45, which is acting leftwards. T1 cos 45. We just found out the value of T1, which is 2 under root 2. So we can substitute it over here for T1. That means the tension in AB is equals to 2 under root 2 times cos 45. And that is equals to 2 newtons. So we have found our tension in AB to be equals to 2. This is part B of question number 4. So it says we need to find out the value of theta and the tension in the string BQ. So over here we have two unknown variables. So we will look at the entire diagram as a system, and the conditions are the same again, that it is in a state of equilibrium. So now when we look at the upward forces equal to the downward forces and the rightward forces equal to the leftward forces, so for this it will be that T2 sine theta must be equals to 1, and for the second condition that will be T1 cos 45 must be equals to T2 cos theta. So we found out that the value of T1 in the previous part was 2 under root 2. That means that the value T2 cos theta must be 2 under root 2 times cos 45, which was equal to 2. So 2 is equals to T2 cos theta. Now if you look closely, that if we multiply this equation over here by 2, that will mean that 2 times T2 sine theta is equals to 2, and 2 is also equals to T2 cos theta. That means that 2 times the tension T2 sine theta is equals to T2 cos theta. Now we have two trig functions, and we can simplify this by dividing on both sides by T2 cos theta. So this becomes 1, the right side becomes 1, and this becomes 2 tan theta. That means that tan theta is equals to 1 by 2, making theta is equals to tan inverse 1 by 2. That is 26.6 degrees. So now we can use this value of theta and substitute it back in the T2 cos theta equation to find out the value of T2, which was the tension in the string BQ. So that means that 2 is equals to T2 cos 26.6. So in order to find out the value of the tension, we need to divide 2 by cos 26.6, and that is equals to 2.23. So with that we have the answer. One is the value of theta over here, and the other is the value of the tension in BQ. So on to question number 5. They say that two particles P and Q of masses 2 mkg and mkg respectively are held at rest in the same vertical line. The height of P and Q above horizontal ground are 1 meter and 2 meter respectively. P is projected vertically upward with a speed of 2 meters per second. At the same instant, Q is released from rest. So part A says that we need to find the speed of each particle immediately before they collide. So before we do that, first we need to make a diagram that represents this situation. So they're saying that they are in the same vertical line. So let's say this is the vertical line, and they're saying that P is 1 meter above the horizontal ground. Let's say this is the horizontal ground, and Q is 2 meters above. So let's say this entire line is 2 meters, so that means that P must be somewhere over here in the middle, and Q is over here at the top where the height is 2 meters. Then they say that Q is projected upwards with a speed of 2 meters. That means that the initial speed of P must be 2. And since it is projected upwards and is moving against the force of gravity, that makes its acceleration equals to -10. On the other hand, for Q, it is held at rest and nothing else is done to it. So that means that the initial speed is 0. Afterwards, it is released from rest. That means that it is moving downwards, which is with the force of gravity, which makes the acceleration equals to 10. And then they have used this keyword at the same instant to indicate that we have to use the same time whenever we use any equation of kinematics. Now in this question we will use those. Now there are three equations that we use. The first is that v is equals to u plus at, where v is the final velocity, u is the initial velocity, a is the acceleration, and t is the time. Second, we use the v squared minus u squared is equals to 2ax formula, where x is the displacement, but we usually just consider that as distance. And the third is that x is equals to ut plus half at squared. The objective of this question is to find the speed of each particle immediately before they collide. So for the speed, we will use the first formula. So for p, the final velocity is unknown. So you write that as v. The initial velocity is 2, as we have established, and the acceleration will be minus 10, and then this is t. So whenever we find the time, we'll just insert that into this equation and find out the velocity of p. As for q, the velocity is also unknown, and since the initial speed is 0, this will just be equals to 10t. So this is what we'll use as our guideline. So in order to find out the time, we need to also make an equation for distance. Now the distance between p and q is 1 meter. That means that both p and q, whatever distance they travel, it must always be equal to 1. For example, let's say they meet somewhere over here, and x travels this distance and p travels this distance and q travels this distance. So it will always be equal to 1. So another assumption we're going to use is that the distance traveled by p plus the distance traveled by q must be equals to 1. Now we must find out the distance traveled by x and distance traveled by q. So for the distance traveled by p, we're going to use this third formula of kinematics. So that is ut. So this becomes 2t plus half times minus 10, which is the acceleration, times t squared. That becomes 2t minus 5t squared. And then the other formula for q for the distance is half times 10t squared, and that becomes 5t squared. So now we can use these two values in this equation again. So that means that 2t minus 5t squared, which is the distance traveled by p, plus 5t squared, which is the distance traveled by q, must be equal to 1. This minus 5 and plus 5t squared get cancelled. That means 2t is equals to 1. When we simplify this, that becomes t is equals to 1 by 2. So this is a time when both p and q collide. Now we have to insert this back into this guideline that we established. So for p, the velocity is 2 minus 10 times 1 by 2. That is 2 minus 5, which is minus 3. This is the velocity. So there is a distinction between velocity and speed. Velocity is speed in a given direction. Now over here we said that the initial velocity of p was 2, and this velocity was when it was projected upwards. So we took the upward direction as positive. So that means that now that its velocity is negative, what that means is that when p was going downward to the speed of 3, that is when p and q collided. So the speed of p was 3. Now as for q, we said it was 10t. So that is 10 times 1 by 2 is equals to 5. The speed is 5. The speed of q is 5. So with that, we're done with part A of question number 5. So on to part number B. It is given that immediately after the collision, the downward speed of Q is 3.5 meters per second. So we need to find the speed of P at the instant that it reaches the ground. So this is a continuation of the previous part, and in the previous part, let's write down the information that they have given us. The first was that the mass of P was equals to 2m, and the other, the mass of Q was equals to m. And then in part A, we found out the speed of both P and Q before the collision. And the speed of P was the speed was 3 and the velocity was minus 3. So I'm going to write this down in terms of velocity. As for the velocity of Q, that was equals to minus 5. Now now we are assuming that this is minus 5 and not 5, because since P has a velocity of minus 3, and initially we were given this situation that P was over here and Q was at the top, and then P was projected upwards. But then using the formula, we found out that the velocity of P before collision was minus 3. So what that minus 3 means is that they collided when P was moving downwards. Hence, that means that the velocity of Q was also equal to minus 5. In this question, we're only concerned with P. So in order to find out the speed, we use the equation of kinematics. But before that, we need some other information, such as the speed after collision, which we will write as P, which is unknown also. Other than that, we also have to find out the distance that it needs to travel, which I'll write down as x. So as I mentioned, that it was traveling downwards. So P was over here. So we need to find out the height above the ground in order to find out the distance that it needs to travel to reach the ground. So that is missing as well. Other than that, we also have to find out the acceleration, which in this case will either be minus 10 or plus 10. This depends on the direction, but when it is moving downwards, it will be equals to plus 10. How will we find out the speed of P after the collision? We can use the conservation of momentum, which says that the mass of the first particle P multiplied by its initial velocity plus the mass of the second particle, which is Q, plus the initial velocity of the second particle must be equals to the mass of the first particle times the final velocity of the first particle plus the mass of the second particle multiplied by the velocity of the second particle. So we can substitute the information with what we already have. So the mass of P was 2m and the velocity was minus 3. And the velocity was minus 5. And then I'll substitute the other equation. So velocity of P is unknown again. Then mass is equals to m. Now they have given us the downward speed of O as 3.5. What that means is that the velocity of Q will be minus 3.5. Since we established the upward movement as positive and downward speed as negative. So this will be negative 3.5. So this becomes minus 6m minus 5m is equals to 2m times the velocity of P minus 3.5m. So this becomes minus 11m and this minus 3.5m goes to the left side, becoming plus 3.5m is equals to 2m times the velocity of P. Minus 11m plus 3.5 is minus 7.5m, and dividing by 2m on both sides, we find out the velocity of P after the collision is minus 3.75. So again, this reinforces the fact that P is moving downwards. So other than that, what we have to find is the distance traveled or the height above the ground for P. So for this, we can use the distance formula which we did in the first part. So for p, that was 2t minus 5t squared. And in this case, we found out that t was equals to 1 by 2. And when we do that, we will find that it is equals to minus 1 by 4. Now the reason this is negative is because the x is equals to ut plus half at squared formula is basically the formula for displacement and not distance itself. But the starting point was a 1 meter point. So the negative 1.4 means that it is 3 over 4 meters above the ground. So now we also have the distance and the acceleration. So now finally we can use the v squared minus u squared is equals to 2ax formula. This 3.75 will become the initial velocity, which is the speed after collision. Because now we have to find out the final speed at the end of this journey from this point where the height was 3 over 4 to the point where height is equals to 0. So in this case, v squared is unknown. Initial speed we will write as minus 3.75 squared is equal to 2 times 10, since we are working with the force of gravity, times x, which will now be equals to 3 over 4. So when we simplify this, v squared minus 3.75 squared is equals to 15. So v squared is equals to 15 plus negative 3.75 squared. V squared is equals to 29.06, and when we square root on both sides, that is equals to 5.39. So this is the speed of the particle P as it reaches the ground. Question number 6. A particle P travels in a straight line starting from a point O with the velocity 6 meters per second. The acceleration of P at time t seconds after leaving O is 8 meters per second where? So they've given us that from the starting point where t is equal to 0 till after 1 second the acceleration is using this equation, and then after 1 second the acceleration is this. Additionally, they've also given us that the starting velocity, the starting speed is 6. So when t is equals to 0, that means the velocity is equal to 6. So for part A, we have to find the velocity of p at t is equals to 1. So we all know that whenever we integrate acceleration, we get velocity. So we only have, that means in order to find the velocity of p after 1 second, we'll use the first formula. So that is, when we integrate that, velocity becomes negative 1.5 t raised to power 3 by 2 divided by 3 by 2 plus c, which is an arbitrary constant. So the velocity becomes minus t raised to power 3 over 2 plus c. Now in order to find the c, we're given this information over here. So when t is equals to 0, velocity is 6. So for v, we can write 6, and t is 0. So 0 raised to power anything is 0. That means that c is equals to 6. That makes the final equation for velocity equals to minus t 3 raised to power 3 by 2 plus 6. Now to find the velocity after 1 second, we just have to substitute 1 in place of t. That means that minus 1 raised to power 3 by 2 plus 6. Anything raised to power minus 1 is minus 1, so this becomes minus 1 plus 6, making the velocity equals to 5 when t is equals to 1. So with that, we're done with the first part. On to part number B. They're saying that given that there is no change in the velocity of p when t is equals to 1, we need to find an expression for the velocity of p for when t is greater than 1. So like in part B, we need to integrate the acceleration to find out the velocity, but in this case we will use the second equation, since that is for when t is greater than 1. So when we integrate this second equation, we find that velocity is equals to t raised to power 3 by 2 minus 6t raised to power 1 by 2 plus c, where c is an arbitrary constant. Now the reason for giving us this statement that there is no change in velocity of p when t is equals to 1 is that we can use this value of v is equals to 5 when t is equals to 1. So you can write that down and substitute it in this equation that we found out for v. So that means 5 is equals to 1 raised to power 3 by 2 minus 6 times 1 raised to power 1 by 2 plus c. So this becomes 5 is equals to 1 minus 6 plus c. So this becomes 5 is equals to minus 5 plus c, hence c is equals to 10. And that means that for when t is greater than 1, the velocity is equals to t raised to power 3 by 2 minus 6t raised to power 1 by 2 plus 10. So that is the second part. This is part C. So it's saying that given that the velocity for p is positive for when t is less than or greater than 4, we need to find the total distance traveled between t is equals to 0 and t is equals to 4. So the main objective is to find the total distance traveled for the first 4 seconds. And other than that, they have told us that the velocity for p is positive from t is equals to 0 to t is equals to 4. What that basically means is that p does not change the direction. And why this is important is that when an object does not change its direction, that means that the distance it travels must be equals to the displacement. And we know that whenever we integrate velocity, we get the equation for displacement. That means that in order to find the total distance traveled, we can just integrate velocity and then we'll get the distance equation and then just apply the limits. So in part A and B, we found out the total velocity for when t was less than 1 and for when t was greater than 1. So we're going to write that down. So for when t was less than 1, we found out that velocity was equals to t minus t raised to power 3 by 2 plus 6. So when we integrate this, we'll find that distance or displacement is equals to minus 2 over 5 t raised to power 5 by 2 plus 6t plus c. Now in this case, the arbitrary constant will be equal to 0. That means that there is no c in this case. Why that is the case is that when t is equals to 0, it is still at its starting point. That means the distance traveled is also equal to 0. So this is for when t is less than 1. So when we apply the limits of 1 and 0, we can find out total distance traveled, and so that is 28 over 5. So 28 over 5 is the total distance traveled from t is equal to 0 to t is equal to 1. Now going back to for when t is greater than 1, we found out that velocity was equals to t raised to power 3 by 2 minus 6t raised to power 1 by 2 plus 10. So now we need to integrate this as well to find out the total displacement or the distance. And when we integrate this, we find out that displacement or distance is equals to 2 over 5 t raised to power 5 by 2 minus 4t raised to power 3 by 2 plus 10t plus c. So now in this case, c will not be equal to 0. That is because we know that when t is equals to 1, the displacement is equals to 28 over 5, as we did over here. So when we write that down, we know that 28 over 5 must be equals to, when we substitute the value of 1 in place of t, and that is equals to 32 over 5 plus c. That means that c is equals to 4 over 5. That makes the displacement formula or the distance formula for when t is greater than 1 equals to 2 over 5 t raised to power 5 by 2 minus 4 t raised to power 3 by 2 plus 10 t minus 4 over 5. Since this was minus, I forgot to say it. So, and now when we apply the limits of 4 and 1, since we already found out the distance for when from t is equal to 0 to t is equals to 1, we will find that when we apply the limit of 4, that gives us the answer of 20, and then we subtract it by when it is equals to 1. When we apply the limit of 1, that gives us the answer of 28 over 5. So now we have to subtract that. So 20 minus 28 over 5 is 72 over 5. So this is the distance traveled from t is equals to 1 to t is equals to 4. So in order to find the total distance, we will need to add this value 72 over 5 plus the 28 over 5 which we found over here, and that gives us the value of 20 meters. So that is the total distance traveled. Question number 7. So let's read it. Two particles A and B of masses 0.2 kg and 0.3 kg respectively are attached to the ends of a light inextensible string. The string passes over a small fixed smooth pulley which is attached to the bottom of a rough plane inclined at an angle of theta to the horizontal, where sine theta is equals to 0.6. Particle A lies on the plane and particle B hangs vertically below the pulley, 0.25 meter above the horizontal ground. The string between A and the pulley is parallel to a line of greater slope of the plane. The coefficient of friction between A and the plane is 1.125. Particle A is released from rest. So for part A, we need to find the tension in the string and the magnitude of the acceleration of the particles. So we have two unknown variables, the tension in the string and the acceleration of the particles. So this entire paragraph is basically describing what is shown in this diagram, but some additional information that they've given us is the masses of the particles which we'll have to resolve, and other than that they have told us that it is on a rough plane. That means that this plane over here where A is sitting, there is the presence of friction. And then additionally they have told us the coefficient of friction, which we write as mu, which is equal to 1.125. And then they have told us that sine theta, with this angle theta over here, where sine theta is equals to 0.6. And then they have told us the initial speed of A, which was 0. So now let's resolve the weights. So for B, since it is hanging vertically, it will only have a downward component of 3. For A, we need to resolve the weight, since it has two components. So it has the downward component and a rightward component which is pull. So for A, we need to resolve its weight since it has two components. One is the vertical component which is pulling it downwards, and the other component which is rightward, which is pulling it downwards on the plane. So this line that I'm drawing is parallel to the plane. So in that matter, this angle over here will also be equal to theta, and since we're resolving the weight, this will become 2 cos theta, and this rightward component will become 2 sin theta. And since it has a downward component of the weight which is pulling it downward, that means that the friction on A will act backwards in this manner, since it is always opposite to the intended direction of the motion. And so now we have to find the tension in the string and the acceleration of the particles. For this, we will use the forces formula, which is that forward force minus the resistive force is equal to the mass multiplied by the acceleration. So this will be different for both A and B. So for A, the forward force is this 2 sine theta force, and also the tension in the string. So for B, the tension in the string is a resistive force since it is pulling it upwards, but the intended motion is downwards. But for A, this will act as a forward force which is pulling it towards the ground. And this tension will be the same for both A and B since they are connected by a pulley. So let's write down the components for the A. Forward force I will write as 2 sine theta plus T, which is tension, minus the resistive force of a friction is equals to m, which the mass is 0.2 and the acceleration is missing. But for B, the forward force is this component of the weight, so which is 3. The resistive force is only the tension and there is no friction since it is not on the plane, is equals to 0.3, which is the mass multiplied by the acceleration. They both have the same acceleration since they are connected. Let's find the value of the friction. So we know that the friction is equals to the coefficient of friction, which is mu multiplied by r. So we have the value of mu, which they have told us as 1.125. And as for r, we know that the particle A is in equilibrium vertically since it is not flying off the plane. So it is like this, vertically. So that means that this r, the normal reaction, is equals to 2 cos theta. Now they've only given us the value of sine theta, which is 0.6. Now an easy way to find out the value of cos theta is to show it in a diagram as a triangle. So let's say that I will draw a triangle, and so sine theta is equals to 0.6. We can write 0.6 as 6 over 10. So that, and sine theta is equals to the perpendicular over the hypotenuse. And let's say the angle inside is theta. So the perpendicular will be 6 and the hypotenuse will be 10. Using the Pythagoras theorem, we can say that the base is 8. And we know that cos theta is equal to the base over the hypotenuse. So the base is 8 and the hypotenuse is 10. So cos theta must be equals to 8 divided by 10, which is 0.8. So we have the value of cos theta. So now we can find out the value of friction, which is mu 1.125 times 2 cos theta, where cos theta is equals to 0.8. And this is equals to 1.8. So we have the value of friction, which we can use for A. So these two are simultaneous equations. So we have plus t over here and minus t over here. So these can be cancelled. So that means that when we solve the simultaneous equation, this will become 2 sine theta plus 3 minus the friction is equals to 0.5a, because we are adding these two values and these two values, as well as minus the friction comes like that. So 2 sine theta is given to us as 0.6. So 2 times 0.6 plus 3 minus friction we found out is 1.8 is equals to 0.5 times a. So 2 times 0.6 plus 3 minus 1.8 is equals to 2.4 is equals to 0.5 a. That means that the acceleration, which I will write over here, is equals to 4.8. But we also have to find out the tension in the string. So this is the easiest equation to substitute in. So that means that 3 minus t is equals to 0.3 times 4.8. And 0.3 times 4.8 is equals to 1.44. That means t is equals to 3 minus 1.44, making T is equals to 1.56 newtons. So we have both the value of the tension in the string, which is 1.56 newtons, as well as the acceleration, which is 4.8 meters per second square. So this is part B. It says that when B reaches the ground, it comes to rest. In the total distance that A travels down the plane from when it is released until it comes to rest, you may assume that A does not reach the pulley. So first let's make a diagram similar to the one in part A. So they said that this is a plane, a rough plane in which there is friction, and this is particle A over here, and it is connected to a pulley which is also connected to a particle B over here, and this particle B is 0.25 above the ground. Now these two particles A and B are connected, which means they have the same acceleration as we found out in part A, which was equals to 4.8, and that means that they also travel the same distance. So for B to reach the ground, as they mention over here, B needs to travel this 0.25 meters over here. That means that A also travels this 0.25 meters. And initially it started from rest. So the reason they're asking for the total distance for only particle A is that when B reaches the ground, that means that there will be no tension in the string. So the tension in the string will become 0. But due to the force of inertia, after A has traveled, for example, let's say this is 0.25 meters, it will also move another distance ahead, and this distance is unknown. And so we need to find out the new acceleration as well as the speed of particle A after it has traveled this 0.25 meters. First, let's find out the speed of particle A after it has traveled 0.25 meters. So again, we're going to use the equations of kinematics, and we can use the v squared minus u squared is equals to 2ax formula. So v squared is unknown, and since the initial speed of is 0, we don't need to write that. Is 2 times acceleration, which was 4.8, times the distance, which was 0.25. So this gives v squared is equals to 2.4, making the final velocity equals to under root 2.4. Now this final velocity becomes the initial velocity at this point. So this becomes the u is under root 2.4. And we need to find out the x2, which is the distance traveled due to the force of inertia. So let's first find out the acceleration using the forces formula. Forward force minus resistive force is equal to the mass multiplied by the acceleration. So in the previous part, we resolved the weight of A in both directions. So we will only use the component of the weight that is acting rightwards. The forward force was 2 sine theta, and the resistive force now is only the force of friction, which we found out as being equals to 1.8, and the mass is equals to 0.2, and the acceleration is missing. And we also found out in the previous part that sine theta is equal to 0.6. This is 2 times 0.6 minus 1.8 is equals to 0.2a, and this becomes negative 0.6 is equals to 0.2a. This means that the acceleration is equals to negative 3. So now we have the initial speed, the acceleration, and we know that the final speed will be 0 because they're saying that A needs to come to rest. So when it is at rest, the final speed becomes equals to 0. So again we're going to use the same formula. So v squared is 0 and u squared will be 2.4 is equals to 2 times minus 3x. This becomes negative 2.4 is equals to minus 6x, where x is equals to 0.4. Now they're asking for the total distance, and remember that A has also traveled this 0.25 meters for when B reached the ground, and since they're connected, they both travel the same distance. So the total distance must be equals to 0.4 plus 0.25, which is equals to 0.65 meters. That is the final answer.